Okay. The big day. The day it all matters. The most important day of the year? It's arguably the most important day of the year. It really is. Certainly, yeah, I'm going to say it's the most important day of the year. Let's draw a picture of a circle and an angle in there. Okay, gentlemen, I really need your attention today. Biggest day of the year, most important lesson of the year. And I know there's a picture already there, but I want to label this picture with some things that we know. Let's see, this is the unit circle. The unit circle means that radius is 1. This is our angle. And that point on the circle is x comma y, right? Because it's at the origin. The circle is centered at the origin. So that point is xy, where this is my x distance and this is my y height of that triangle. And then let's write the cosine of that angle. Let's see, cosine is adjacent over hypotenuse. So that would be x over 1. And so, the 1 doesn't really matter at that point. X is equal to cosine theta. Let's write sine of theta. Sine of theta, SOHCAHTOA, opposite over hypotenuse. So y over 1. So y is equal to sine of theta. Like, this is the big deal of the unit circle, is that the cosine is the cosine of the angle is the x coordinate, and the sine of the angle is the y coordinate. And so if you know the coordinates, you know the sine and cosine. Or if you know the sine and cosine, you know the coordinates. Most of the time we're going to work these problems by knowing these coordinates, which will allow us to know the sines and cosines. If you get them confused, x comes before y, just like c comes before s, so like they're alphabetical, x comma y, cosine comma sine. X is the cosine, y is the sine. I've sort of hinted at that before with the quadrant thing. Cosine is positive on the right because it's a left-right thing, it's an x thing. Sine is positive on the up quadrants because it's a y thing. X is the cosine, y is the sine. So as we look at our picture, you know what? Let me pause here. With this is let's fill in the quadrantal angles first. So 0, 90, 180, 270, 360. Fill in the quadrantal angles in degrees. Let's now fill them out in radians. So 0 and 2 pi. Halfway around is pi. You can also use that answer blank as the fraction bar, so you could write that as pi over 2 and 3 pi over 2. I know many of you know more than what we're like. You could race ahead of me on this, but I'm asking you not to take it slow, because we want this stuff to seep in, not just blow through it and be like, yeah, I kind of know all this. Like, let it soak in, because you need to understand it the rest of the year. Okay, the unit circle, the reason it's called the unit circle is because r is 1, radius is 1. So what are the coordinates over here at 0 degrees? What's the coordinates of that point?
0, 0. 1, 1. 0, 1, 0.
I'm hearing all kinds of answers.
Yeah, 1, 0.
Okay, the origin is right here, right? This is 0, 0. So this point is 1, 0. point is 1, 0. All right, now that we got that one down, what's this top point right here? 0, 1.
Does it not matter like the radius?
Right. 1, 1 would be like out here somewhere, right? That'd be out off the circle.
Well, the point of the unit circle is that it would change, but the point of the unit circle is that the radius is 1.
Yes.
So the radius would never change?
Correct. For the unit circle, the radius is 1. Always.
Okay.
That's what makes all of it work. How about this point over here on the left? Negative 1, 0, and the point at the bottom, 0, negative 1. Okay, we got all our quadrant points on there. But remember that the whole point of the unit circle, the whole big deal about the unit circle, is that x comma y is the same thing as cosine of that angle comma sine of that angle. So while we were writing down ordered pairs, x and y, what we also were writing down, we weren't really thinking about it, but what we wrote down was cosine of the angle comma sine of the angle. So I'm going to have to do a little back and forth here. I can't put them both on the screen, but you can look at both. Back to the notes packet page. So what's the sine of 0 then? The sine of 0 means I go to 0 degrees, or 0 radians, I guess it wouldn't matter. The sine is the y-coordinate, so the sine of 0 is 0, because that's the y-coordinate at 0 degrees. How about the sine of pi over 2? In fact, you could use the circle that's right there. It's already got it on there. What's the sine of pi over 2? 1, because that's the y-coordinate at pi over 2. How about the sine of pi? Sine of 3 pi over 2? Negative 1. And the sine of 2 pi? 0. If you know that the r is 1, the radius is 1, and you know that x goes with cosine and y goes with sine, then it's not so much a memorize all these values, it's understand that x goes with cosine, y goes with sine, and then you can answer all the questions. How about the cosine of 0? The cosine of 0? 1, because that's the x coordinate at 0 degrees, or 0 radians, either way.
This is the physics thing. I have no idea what's going on. Because you go, why do you sin? Because of your ex. It's physics. That's what
It is very much related to physics. If you draw your angles correctly in physics, it is very much related that the x goes with the cosine and the y goes with the sine. So when you're doing those free body diagrams and the weight and the normal force and all that stuff, yep, definitely. How about the cosine of pi over 2? 0, because that's the x coordinate at pi over 2. Cosine of pi? Negative 1, because that's the x coordinate at pi. Cosine of 3 pi over 2? 0, because that's the x coordinate at 3 pi over 2. And the cosine of 2 pi is 1, because that's the x coordinate at 2 pi. The coordinates tell you the cosine and sine. X tells you cosine, y tells you sine. All right, back to the big unit circle here. Let's now look at all the 45 degrees, the middle markers. So 45 degrees and 135 degrees and 225 and 315. And then let's also put those on in radians. So pi over 4 is the first one. What's the over 4 marker in the second quadrant? This is what we did yesterday. 3 pi over 4. And the over 4 marker in the third quadrant? 5 pi over 4, because remember we're 1/4 past 1. And in the fourth quadrant, we're 1/4 shy of 2, so 7 pi over 4. Okay, now is where things get a little bit more interesting. Because if I draw the triangle on this picture, things are going to get a little bit ugly. Let's go back to this picture. We'll mess this one up, and then we'll go back to our clean version here. So I'm going to draw a triangle in, and you can see if we did this for every angle, it would be a mess. But we'll do it once on each of our pictures here. So I'm going to draw one triangle in at the pi over 4 angle. We know the radius is 1. Let's see, this is one of those special right triangles where this is, I don't want to use x and x. Let's use s and s square root of 2. Right, the pattern. So if s square root of 2 equals 1, this is our geometry pattern that we're doing, then what does s equal? 1 over square root of 2, which we would clean up to be root 2 over 2. So from geometry special right triangles long ago, if the hypotenuse is 1, then each of these sides is root 2 over 2. So we just found the x-coordinate and the y-coordinate of that point. Let's go back to the big picture here. So we just found the x-coordinate and the y-coordinate of that point. They're both root 2 over 2. Well, use some symmetry. I don't think I need to draw many more triangles here. At 3 pi over 4, which one's negative? The x is negative because it's going to the left, but the value is the same. So negative root 2 over 2 for the x. The y is still up, so that's a positive root 2 over 2. By the way, that also still fits with the idea of all students take calculus. The signs are positive in the second quadrant, the cosine is negative. How about into the third quadrant? The values are still root 2 over 2, and they're both negative, because left is negative and down is negative. And or all students take calculus means only tangent is positive in the third quadrant. And then in the fourth quadrant, the y is negative, but the x is positive, because we went to the right and then went down. But like all the values are the same. In fact, the x's and the y's are the same because that's the middle angle. So let's get the highlighters out again. And let's highlight all the over 4s, all the middles. The same color. It doesn't matter what color you pick. Anyone like to borrow an orange? Since I'm now through with my orange. Oh, you want me to hit him with it? Accidentally hit Jacob with it? Accidentally peg him with it? Okay, back to the notes packet. But keep your big circle there handy. So the sine of pi over 4. If I want the sine of pi over 4, that means the y-coordinate at pi over 4. So the y-coordinate at pi over 4 is root 2 over 2. And we kind of just did all this. Now instead of talking about, we just filled this out on the circle rather than on the paper. The cosine of pi over 4, that would be the x-coordinate. So that's root 2 over 2. I feel like I should have done these backwards because I've got the y column first and then the x column. At 3 pi over 4, sine is up, so that's positive. Cosine 3 pi over 4, that's on the left, so that's negative. You're racing through these. Third quadrant, they're both negative. Fourth quadrant, sine is negative because it's down, but cosine's positive because it's to the right. But all the values are root 2 over 2. I guess I'll go ahead and warn you now. On the test, there's a whole bunch of these. They're only 2 points each, but there's no partial credit. If you miss the sign, you miss the problem.
How many questions are on the test?
I'd have to go back and look.
It's on block day, right?
It is. There's not a block day next week.
Is it a 2-part test?
It's a 1-part test. So by the time we get there, you'll know these super well. Shouldn't you? I think it's all no calculator. Okay, tangent. We didn't talk about tangent earlier. Let's look back at our picture up here. Maybe we should add this right here. Looking at my picture, SOHCAHTOA, what's the tangent in terms of... Well, careful, it's opposite over adjacent, so it's y over x. So that also means, yeah, you're jumping ahead a little bit, but that's fine. It also means that it's sine over cosine. Tangent is sine over cosine. Although, for us, we're probably just going to think, for now anyway, that it's y over x. Because we're thinking in terms of coordinates. So the tangent of pi over 4, y is root 2 over 2. X is root 2 over 2. I like this one. So 1, right? You don't have to keep it, change it, flip it, or fix square roots. It's like something divided by itself is 1. So the tangent of pi over 4 is 1. The tangent of 7 pi over 4, let's see, the sine is negative, root 2 over 2. The cosine's positive, so that's negative 1. But remember, all students take calculus. Like, fourth quadrant, tangent should be negative. And it has the same value as all the other over 4s. Which just happens to be negative. Alright, turn the page on the notes page. But the focus goes back to the big circle. Because now we want to do the over 3s. So multiples of 60. So 60, 120, 180 is already there. Whoops. 240, 300, 360. And then as we saw yesterday, all of these are over 3. So pi over 3 is 60. How about in the second quadrant? What over 3 is 120? What's this angle in radians? 2 pi over 3. Because you're pi over 3 shy of pi. And then in the third quadrant, when you're pi over 3 past pi, you're at 4 pi over 3. And then in the fourth quadrant, when you're pi over 3 away from 2 pi, you're at 5 pi over 3. Okay, I need coordinates. So I'm going to go back to the notes packet and draw in a triangle. Again, because I don't want to draw in a whole bunch of triangles on my nice big circle. Radius is 1. That's a 30, 60, 90. So this one's a little easier. Hypotenuse is 2s. Short side is s. Long side is s squared root of 3. We talked briefly about that yesterday, those 30, 60, 90 triangles. So if 2s is 1, that means s is 1/2. So my x-coordinate is 1/2. And s squared root of 3 would be root 3 over 2. So my y-coordinate is root 3 over 2. Okay, so if I keep one eyeball on that while your other eyeball looks at the big picture here.
What's the x length?
So the x length was the short side, right? That's the x length. So that's 1/2. And the y length was √3/2. So before you forget that, you come over here, and the x length was 1/2, and the y length is √3/2. Yeah, the x length is 1/2, and the y length is longer. Sometimes just knowing which side is short and long is good enough, right? X is shorter than y, so x is 1/2, and y is the longer side. Now you can fill in the other pi/3s because of the symmetry. So in the second quadrant, it's the same set of numbers, but who's negative in the second quadrant? The x would be negative, so -1/2, but a positive √3/2. And then in the third quadrant, at the over 3's, x is negative, and the y is negative, but the values are the same, 1/2 and √3/2. And then in the fourth quadrant, x is positive, and y is negative, so negative √3/2. Grab a different color highlighter and highlight all of the over 3's. All of the steep angles. And I would ask you to notice the symmetries, but we already noticed the symmetries. We used the symmetry to fill in all the blanks. So all the values are the same. All the x's are 1/2. All the y's are √3/2. It's just a matter of positives and negatives. Okay, back to the notes page. I'm going to say we don't need to, you know what, we don't need to fill in the sines and cosines, but let's do fill in the tangents. Right? The sines and cosines we already have on the page, but the tangents, tangent of pi/3, I'm gonna peek here at my big picture. Tangent's y/x, so that's √3/2. X is 1/2. So you could keep it, change it, flip it. You could multiply top and bottom by 2. However you get there, the answer is square root of 3. The tangent of pi/3 is √3. Okay, the tangent of 2 pi/3, I don't think I need to do this again. How did you know it was negative √3?
Because x is negative, so just multiplying by -3.
Okay, so the values are the same. So it's definitely still √3. But the x is negative, so it's going to be negative. Another way to say that, or another way to remember that, is all students take calculus. Tangent in the second quadrant is negative, so negative √3. But the reason it's negative is because the x was negative, so that's all the same reasoning in the end. All right, let's look at the, let's see, what do we want to do next? Let's go back to the big picture and label all the 30s, or all the over 6's. So 30, and then 30 shy of 180 is 150, and 30 more than 180 is 210, and 30 shy of 360 is 330. Okay, this one I can fit all on the screen because they're all the shallow angles. All of those are over 6. So the first one's easy, pi/6. In the second quadrant, if we're pi/6 away from pi, then we'd be at 5 pi/6. And if we're pi/6 more than pi, we're at 7 pi/6. And if we're pi/6 shy of 2 pi, that would be 11 pi/6. And again, I could draw the triangle on this page, but that would really junk things up. So I'm going to go back to the notes page and draw a triangle. Once again, the radius is 1. That's why the unit circle works, because the radius is 1. It's another 30, 60, 90 triangle. So across from 30 is s. Across from 60 is s square root of 3. And the hypotenuse is 2s. So it's really similar to that 60-degree triangle. It's just things are flipped. So s is still 1/2, but now the 1/2 is the y-coordinate. And the x-coordinate would be root 3 over 2. So it's the same values, but they're flipped. But that makes sense because 30 to 60 traded places. So the x-coordinate at pi over 6 is the long side now, so that's root 3 over 2. Sine is the y, which is the short side, so that would be 1/2. Or you just trade places with the x's and y's from the 60.
What if you somehow you decided like where the
Okay, because this is a 30, 60, 90 triangle, and from geometry long ago, across from 30 was s. Like this is a pattern that you had to memorize in geometry. S square root of 3, and 2s. And you would put those on triangles and figure out what s is and then find the other lengths. Does that sound familiar? Back to our big picture here. So now you can fill in all the other ones because the values are the same. Just be careful with the pluses and the minuses. In the second quadrant, x is negative root 3 over 2, comma 1/2. In the third quadrant, they're both negative. Negative root 3 over 2, negative 1/2. In the fourth quadrant, x is positive. It's the long side, so it's root 3 over 2. Y is negative. It's the short side, so it's 1/2. And now we've got all of our unit circle filled in. Let's go back to this page. I didn't copy quite right. I wanted to see tangent of pi over 6, and then tangent of, let's say, 11 pi over 6. Tangent of pi over 6. I know that's y over x. The y side is the short side. The x side is the long side. Uh-oh, that one's not quite as easy as the last one. Twos will go away, and then you fix it, root 3 over 3. What about the tangent of 11 pi over 6? Good. I don't have to go through all that again. It's root 3 over 3 for sure, and then I need to be careful. In the fourth quadrant, it would be negative. Okay, back to the main picture. Oh, we need to highlight the over 6s. So pick your favorite color and or I guess it's your third favorite color at this point. Okay, down at the bottom, I want to try to summarize all of this, because all the shallows, all the middles, and all the steeps have some things in common. The shallow, the middle, and the steep in each quadrant. What's the denominator for all the shallows? Oh wait, I should be careful what I'm asking. What's the denominator of the angle of all the shallow angles? Is 6. Yeah, all the denominators for the values are 2, so that's not a big deal. But the over 6 angles are all the shallow angles. How about the middle angles? What's that denominator? 4, and all the steep angles are 3. And I'm going to do x comma y, which is the same thing as cosine comma sine. So I'm not worried about pluses and minuses. I just know that in the shallow triangle, the x-coordinate is the long side. This is how I do it. In the shallow triangle, the x-coordinate is the long side. So that's got to be root 3 over 2. And in the shallow triangle, the sine is the short side, so that's 1/2. In the middle angle, the x and y are the same, right? Because that's all the 45s. That's all the over 4s. And all of those triangles are root 2 over 2. And it doesn't really matter if you get the x and y backwards because they're the same. Although, careful about the negatives. Yes, it doesn't matter there. And then for a steep triangle, the x length is the short side, so that's 1/2. And the y length is the long side, so that's root 3 over 2. And then lastly, let's go ahead and make a tangent column here. The tangent of anything over 6, you remember what that was? That was root 3 over 3. I mean, if you don't memorize, you don't have to memorize tangents because you can always do y over x. So some people don't ever memorize tangents, they just do y over x every time. Other people, because we do this so often, they're like, look, I'm just going to memorize the 3 tangent values and that way I don't have to do y over x again. Your choice. How about the tangent of over 4?
1.
That's an easy one. Memorized or not, it's 1. Y over x. And then the tangent of over 3 was root 3. Now, there is a little bit of trick if you want to memorize. Call it the tangent 3 trick. If your denominator is 3, your tangent has 1 3 in it. If your denominator is 6, your tangent has 2 3s in it, and 2 3s make 6. That's just kind of a dumb way to remember it, but people get those two backwards, and so this is an easy way to maybe connect that over 3, the tangent is root 3, over 6, the tangent is root 3 over 3. We haven't put it on here yet. I've said it a few times, but it's sort of implied, but all students take calculus sort of fits in as well here. Helps you keep track of the positives and negatives. Okay, so with that sort of at your side, let's jump back to the notes packet here. Most people end up just straight up memorizing the first quadrant. Well, let's go back and forth here. What we should look at next. Somebody counted up one time, and I think there were 64 blanks, or maybe it was 66 blanks. And so, like, oh, I got to memorize 66 things. Like, no, not really. Like, all of the symmetry there. You need to know the first quadrant. But even then, how much of it is memorizing, and how much of it is can you get by with sort of figuring out long sides and short sides? There's not a whole lot of memorizing to do, is the hope. If you do memorize, you only memorize the first quadrant. All right, back to the notes page here. The sine of pi over 6. Let me show you how I do it. There's a variety of ways to do this. Some people just have memorized the sine of pi over 6 is 1/2. If you don't have that memorized, then you sketch a quick little pi over 6. You know that's the shallow angle. You know sine is the y-coordinate. The y-coordinate looks like a short side, so it's 1/2. That's how I do it without really memorizing anything.
Can we get one of these on the test? So we just fill it out and then we use it?
So, no, because I don't want you to, yeah, exactly. I don't want you to, it's a great question. Can I get one of these on the test to fill it out and use it? The answer is no, because time-wise, that would be probably beneficial for this test. But in tests moving forward, this stuff shows up sort of randomly, and you don't really have time to, make a nice, pretty neat unit circle with everything on there and then go use it. Like, you need to have a better way to get there. So what a lot of people do, so I'm not going to give you a blank one, but what a lot of people do, and what I couldn't stop you from doing it even if I wanted to, is when they get their test, they'll do a quick first quadrant and do everything in the first quadrant. And then refer to that. So that's sort of in the middle of, we want you to be able to answer these without drawing out the full thing. I say that, and I draw out a little picture almost all of the time. You know what? While we're at pi over 6, cosine would be the x-coordinate. So I look at the x-coordinate and I think, oh man, that's a long side. All the long sides are root 3 over 2. Right? There's only so many values on the picture. All the short sides are 1/2. All the long sides are root 3 over 2. All the middle sides are root 2 over 2. And that's all you need to know. I mean, that's a bit of an exaggeration, but those are the only values you really need to know. Sine of pi over 3, let's see, that would be a steep angle. Sine is the y-coordinate, so that's root 3 over 2. Again, I'm trying to memorize as little as possible. Cosine's the x-coordinate.
Good morning, this is Matt and Ashley.
So that's 1/2. The assignments worksheet 6. Please start trying some of these because this is a big deal. If you look ahead at a worksheet 7, it's like, oh, it's more of the same thing. And the rest of the packet is like more of the same, more of the same, more of the same. Because it's that important.
Will we ever talk about sine waves?
I hope not.
We will.